We will have 3 papers in this session. Let's welcome the first speaker from Boston College.
Thanks for having me here. I'm so glad to present my job market paper. I'm currently the job market candidate at Boston College, and I'm glad to present at HKU, which is my alma mater. So this morning I navigate to this place very easily. So the paper is titled School Choice, Teacher Access, and Student Outcomes. So we know teachers are one of the most important factors in determining student outcomes. However, literature has documented that the distribution of high-quality teachers is unequal. Specifically, high-quality teachers tend to teach more advantaged students, which remains as a key driver for the persistent test score gap between students from different income and racial groups. And furthermore, introducing charter schools, a new type of public school that widely adopted in US, may further reshape this existing student-teacher matching, because opening a new charter school will provide both job opportunities for teachers and also enrollment options for students. However, if you look at existing literatures on charter schools, most of them tend to focus on how charter schools affect the students' choices, but abstract away from the teacher side responses. So this leaves the impact of charter schools on teacher access still being understudied. So in this paper, I investigate how the entry of charter schools affect teacher access at existing public schools by jointly considering the decisions of teachers and also students. And more broadly, I provide a unifying framework to understand this inequality in teacher access by providing a model that incorporates teacher hiring, school choice, and also test school production. So to summarize a little bit, in this paper, I aim to answer the following research questions. So first, how does this entry of charter schools affect the joint sorting patterns of students and teachers? And second, what is the role of this joint sorting of students, teachers in reshaping this teacher access and hence student outcomes? And finally, if we do find some inequality concerns, can policymakers achieve a more balanced teacher access, but at the same time providing more choices for students? So first, before I go to the details, let me give you a preview of my main findings. So first, using a reduced form analysis, I document that both teachers and high-income students tend to jointly sort into new charter schools, particularly for those from low-income public schools. So those schools serving more than 80% of low-income students. And specifically, the entry of charter schools is associated with the reduction in average teacher value added, which is a way to measure teachers' effectiveness, and also the increase in the share of low-income students at existing school. And these impacts are much larger if we focus on low-income public schools. And second, to better understand this role of joint sorting of students and teachers, I built an estimated structural model, and then I show that this charter school expansion exacerbates the joint sorting of students and teachers for high-income students. And specifically, by conducting a set of counterfactual analysis, I quantified that this joint sorting for high-income students mechanism enlarged the test score gap between high and low-income students by 0.006 standard deviation just 1 year after entry of 7 charter schools. And this is equivalent to about 2,400 lifetime earnings gap between these two groups. And finally, I simulate a set of policies that aim to improving the accessibility of charter schools to low-income students. And I show that by providing bus services and also relocating those charter schools from high-income neighborhoods to low-income neighborhoods, we can effectively mitigate this enlarged test score gap due to charter expansion, but at the same time maintaining the test score level similar to the pre-entry case. So for the time's sake, I will just skip the literature review, but broadly, this paper connects to the literature on the unequal teacher access and also literature on the charter schools. So let's go to the detail. Let me first give you some detailed institutional background about charter schools, maybe probably a new concept for non-US audience. So charter schools are public schools operated by individuals or organizations. So they are public, which means they are funded by the government and also tuition free, and also subject to accountability. However, compared to traditional public schools, they enjoy a greater degree of freedom in terms of location choice, curriculum design, teacher hiring, school management, and so on. And the literature do found that because of this special features, many charter schools, they enroll a quite different student bodies compared to the traditional ones. And nowadays, charter schools play a very important role in the U.S. public educational system. So there are more than 8,000 charter schools enrolling 3.7 million students and also 25,000 teachers. And back to my empirical context, which is North Carolina. So this state first approved charter school in 1997. And at the very beginning, they set a 100 school cap on the number of charter schools. So we can see this cap was reached quickly after the first opening. But in 2011, North Carolina removed this cap, and then we see a rapid expansion of charter schools again. So in this paper, I will focus on what happened after this 2011 policy shift. And a little bit about the data I use this paper. So this data set includes all public schools, both traditional ones and charter schools in North Carolina before and after the policy shift. I have detailed information on students and teachers. And also, I can observe the student-teacher matching at the cross level, which allow me to estimate the teacher value added. And finally, I can also observe a bunch of school characteristics. So now let me give you some motivating evidence regarding this impact of charter schools. So first, a very important feature of charter schools in North Carolina is that most of them tend to locate in richer neighborhoods and enroll a much higher share of high-income students compared to the traditional public schools. So traditional ones usually enroll about 40% high-income students, but many charter schools enroll more than 60% or even 70% of high-income students. And because the literature has found that both teachers and high-income students, they tend to sort into schools with more high-income students. So we wonder whether this feature will allow charter school to attract both high-income students and potentially high-quality teachers from existing public schools. So to investigate this, I first implement a staggered defensive analysis or like an event study thing, utilizing this policy shift occurred in 2011. So starting from 2012, in each year, we have a batch of charter schools opened. And I include traditional public schools from the largest 3 communities in North Carolina as my sample, which enroll about 60% of the public school students in North Carolina. And I simply define a school being treated by this entry of charter schools if it's located within 5 miles of at least the new charter school. And I include schools located between 15 to 30 miles away from any new charter school as a control group. But I also did robustness check by varying the size definition, so basically the results hold. And I also allow the treatment intensity to vary by the size of charter schools, which is measured by the number of seats. So specifically, per unit treatment is 500 seats provided by new charter schools. All right. So I estimate this following equation using the recent developed staggered defensive to deal with the potential bias. And my focal dependent variables include a bunch of teacher characteristics, such as the average teacher experience, average teacher value added, and also the student income composition, which is measured by the share of low-income students. All right. So let me give you the first piece of motivating evidence. So this shows that after the entry of charter schools, the average teacher experience at nearby public schools decrease. And if we restrict the sample to low-income public schools, then we see a much larger reduction at those schools. And we have similar pattern hold for teacher value added. So overall, teacher value added decrease, but with a much larger reduction among low-income public schools. And regarding the student side responses, I found that the share of low-income students increased at existing school and particularly at low-income public schools. So overall, I also did other analysis on other dimensions such as the teacher turnover rate, class size, enrollment. And specifically, I found a negative impact on student test score at low-income public schools, even though the results is a little bit noisy. But overall, what we learned from this reduced form analysis is as follows. So under the expansion of those new charter schools, particularly those in predominantly enroll high-income students, we found that both teachers and high-income students jointly sorted into those new charter schools, especially for those previously from low-income public schools. And this heterogeneity implies that a potential mechanism can be the case that because students and teachers, they have preferences for high-income students, so this induces these sorting behaviors to those new charter schools. And this preference for high-income students has already been documented by other literature separately. But a limitation of this analysis is that the student income composition at each school is indeed an equilibrium outcome of students and maybe teachers' choices. So this means that this joint sorting for high-income student mechanism can be quite context dependent. So for example, the same charter school, if located in a different neighborhood, may enroll a different share of high-income students. And this joint sorting for high-income students mechanism may no longer in effect. So to better understand this role of joint sorting and also to provide more generalizable policy implications, I built and estimated a structural model. Yes.
High-quality teachers with Chinese schools, because that they provide higher salary, or is like because they can teach better students?
Yeah, so one thing I didn't cover is like charter school, they can provide a different salary schedule to teachers. But if you look at the average teacher salary, actually charter schools in North Carolina pay lower than the traditional ones. And this hold even you control a certain group of teachers with the same experience, education. So not just the composition in fact, but overall charter school pay lower than the traditional public schools, even though the difference is not that large, but that seems like wage is not the main mechanism here. So in this paper, I will argue that the student income composition should be the main mechanism, given this special feature of charter schools. And also this serves as a kind of like an amenity for teachers besides wage. Yeah. All right. So before I go to the details of the model, let me first quickly talk about how I incorporate the reduced form evidence that I observed to the model. So first, we found that both students and teachers, they're sorting across schools. So to incorporate to model that, so to incorporate this sorting patterns, I model a two-sided matching process between students, teachers, and also between teachers and schools, and also a one-sided matching between schools and students. And importantly, to address the limitation of the reduced form funding, I model the student income composition at each school as a realized equilibrium of student choices on the rational expectation. So let me go to the details of the model. So this is a static three-stage model. The first is a hiring stage, and we have a school choice stage, and also a test score production stage. So in the hiring stage, each school will observe a bunch of teachers' characteristics, and then they send offers to their preferred candidates. And once teacher received their offers, they chose their most preferred offer from her offer set. And then we have this teacher school match being formalized. And then once teachers and schools are matched, we go to the second stage, which is the school choice stage. Now students observe the realized teacher characteristics at each school, and then they also form an expectation about the decisions of other students so that they can calculate what is the expected share of high-income students of the incoming cohort. And then based on this expected share of high-income students and also other school characteristics, they chose their most preferred school. And finally, students are enrolled at each school, and then they are randomly assigned to teachers, and we go to the test school production stage. So let me go to the details of each part of the model, starting from the teacher hiring stage. So for the teacher hiring, this is a two-sided matching thing. So schools will first evaluate teachers based on a bunch of teacher characteristics, including their teaching experience, value added, and also educational level. Specifically, each school form a belief about what is the probability of teacher accepting my offer if I send one. And then they solve the following problem by making the offer decisions. So specifically, they want to maximize the expected total value of teachers they can hire, subject to a capacity constraint and also a tenure constraint. And then once they send out the offers, now each teacher evaluate the schools based on a bunch of characteristics, such as the moving cost if I switch, other school characteristics, including the existing student body characteristics, and also the wage that they can receive either from the traditional public school or the charter school, and also a preference shock. So they just chose their most preferred offer, and then we're done with this stage. And then we go to the school choice stage. So specifically, a student value the average teacher value added at each school, and also the expected share of low-income students at each school, and also other characteristics such as related to the traveling distance, the type of schools. So for example, whether this school is my assigned neighborhood school, a charter school, or a magnet school. And then they, based on their belief, they make their most preferred, they chose their most preferred school. Finally, when students enroll at each school, we go to the test score production stage. So a student test score will depend on a bunch of students' individual characteristics, which is exogenous, and then the peer and the school characteristics that realized in equilibrium, such as the share of low-income students in the equilibrium, the class size in the equilibrium, and also the average teacher value added that realized in the equilibrium. So to close this model, the equilibrium is defined as follows. So this will consist of a set of decisions and beliefs, such as in the equilibrium, each party solves its problem, and also the beliefs are consistent with the decisions.
Yeah. Charter schools can choose which student to admit.
Oh, so charter school have to use random lottery to admit students. So that's why I model this as a one-sided matching in the school choice problem. But it can be the case that we have capacity constraints. But according to the data, only about like 10 schools reach the capacity constraint each year. So I just abstract away from the capacity constraints.
From your description, it seems like charter schools are very much like the public schools. So it looks like a difference that can attract the students and the teachers.
So for the students, in reality, many charter schools, they can use, so for example, they can choose where to open the school. So we see like many charter schools, they located in richer neighborhoods, which inherently allow them to attract the high-income students. And also charter schools are not required to provide bus services. So this also implicitly increase the traveling cost for low-income students. And third, many charter schools, they use different curriculums, such as they emphasize STEM education, since they are more attractable to high-income families. And in the paper, another mechanism that I emphasize is like because charter school may already enroll a much higher share of high-income students. So high-income students may simply choose a charter school due to this peer preference. So that's all the reasons. But in the model, like when I model the student choices, I just use this charter indicator to capture all of this. But I do include a random coefficient to capture the observable heterogeneity. Yeah. So let me just quickly talk about the main identification challenge I faced when I estimate the model. So the first is like the teacher hiring is the two-sided matching problem. But in the data, I only observe the realized matching outcome between teachers and schools. Mm-hmm. So to solve this, I use the identification strategy proposed by Biase, Chow, and Sproul's paper, which is to infer a subset of offers for each teacher as follows. So I first impose a mild assumption on the school's preferences by assuming that schools will weakly prefer all the teacher characteristics, which include experience, value added, and education. So in this sense, in this setting, I think this is a reasonable assumption. And then based on this, under this assumption, I go to the data, and if I observe school A hire a teacher with certain characteristics, then any teacher with weakly better characteristics should also receive an offer from that school. So using this procedure, I can infer offer set for each teacher, and this inferred offer set will allow me to separately identify the student-teacher characteristics. And the second is more common challenge, which is the endogeneity concern in the student utility function, which is the share of low-income students can be correlated with the school observable characteristics. So for example, some schools may emphasize athletics, and high-income families may prefer that characteristics more than low-income families, and then we have endogeneity concern. So to do so, I use the instrumental variable strategy with which constructed such as in Alanda and Kwama's paper, utilize the nearby neighborhood characteristics and also nearby charter school share to construct the instrument. So with the estimate, I won't give you the detailed estimation results, but let me just emphasize some key findings. So first, both students and teachers do have a very strong preferences for high-income students. And second, low-income students, they face a higher traveling cost, and they also value school bus services more. So this will be incorporated in my counterfactual policy design. And in terms of the preference for charter schools, we do find high-income students, they prefer charter schools more, but we have a large degree of heterogeneity. All right. So now let's finally go to the counterfactual stage. So using this estimated model, now I want to answer the remaining research questions. So first is to better understand this role of joint sorting for high-income students. So to do so, I simulate the entry of charter schools in my focal district that I use to estimate the preferences, which is the Mecklenburg School District. I simulate the entry of charter schools that actually occurred from 2013 to 2016, which there are 7 charter schools in total. And I first simulate the baseline entry case with the estimated preferences. And then I simulate the entry again, but now turning off both teachers and high-income white students' preferences for this share of high-income students within the school. And finally, I also simulate a case when I only shut down teachers' preferences. So first, in the baseline scenario, when you simulate the entry, this entry of charter school decreased the test score gap for all students. But we see this reduction concentrated among low-income students. And as a result, we see an enlarged test score gap after entry. And then once we shut down this joint sorting for high-income students, we found now that we have a much larger test score reduction. And importantly, in this scenario, test score reduction concentrated among high-income students. So to interpret this results, this joint sorting for high-income students, to a large extent, prevent high-income students from being hurt by this entry of charter schools, and leaving low-income students being mainly hurt by this entry of charter schools. And as a result, joint sorting enlarged the test score gap post-entry. So this is the role of joint sorting, and people may ask, do we really need a joint sorting model to understand this? Or in other words, if we only model the sorting of one side, can we just will we just get this general pattern, and the sorting of the other side only contribute to the result marginally? So to see this, the necessity of incorporating joint sorting, I simulate third case, which is I only shut down the teacher side sorting. So I choose to shut down the teacher side is to echo the existing literature that they tend to extract away from the teacher side responses when they think about the impact of charter schools. And what I found that if we ignore the sorting of the teacher side, we will falsely predict the positive impact of charter school entry of student type schools. So overall, by comparing the 3 scenarios, we can see like whether you ignore the joint sorting or sorting of one side, we will get very misleading policy implications. So it's necessary to incorporate the sorting responses of both sides when you think about the impact of charter schools. And finally, let me use the last 3 or 5 minutes to talk about the policy implications. So we already found that joint sorting may enlarge this test score gap, but we want to know like whether policymaker can achieve a more equalized teacher access without banning charter schools. So to do so, I simulate a set of policies that aim to improving the accessibility of charter schools to low-income students, which include first providing bus services to charter schools, which is not required in reality, and second, continue providing bus services and further relocating new charter schools to low-income neighborhoods. And what I found is that simply providing bus services is effective in closing this achievement gap. But at the same time, we still see a negative impact on test scores. But further relocating charter schools to low-income neighborhoods will have a similar impact in this gap closing. But at the same time, we see that the test score level is very similar to the pre-entry case. And even like low-income students, they're even slightly better off compared to the pre-entry case. So this analysis suggests that by carefully designing policies related to charter schools, we can achieve a more equalized teacher access without sacrificing the overall efficiency too much. So overall, let me just conclude. So in this paper, I first utilizing this policy shift in North Carolina to document this joint sorting pattern of students and teachers on the charter school expansion. And then by modeling a unifying the framework of teacher hiring and school choice, I show that by how much this tested school gap is enlarged due to joint sorting on the charter expansion. And also I provide policy implications showing that policymakers can actually achieve a better balance between school choice and teacher access without just banning charter schools. And more generally, this besides charter schools, this framework can be also applied to evaluating other educational policies, especially for those that will have direct impact on both teachers and students. So one typical example is the recent school closure or consolidation wave that happening in the U.S. public school system, which directly affect both the teacher labor market and also the students' choices. So yeah, that's all, and any feedback will be highly appreciated. Thank you. You have 3 minutes. Yes.
Good question. In terms of your final experiment, it seems like all these 3 policies you are proposing is a little bit like it's kind of costly. Like the government actually need to spend more money on these charter schools by providing either bus or open the school in the low income. So when you think about this welfare change, there will be also a cost side that comes in.
Right. So in this policy, like I don't have it's not a like budget neutral policy implication. I would say like opening like providing bus services should be more costly. But relocating new charter schools, I'm more thinking about like in the future if you looking at the application of charter schools, maybe we should emphasize like charter schools should prioritize locations with more low income students. But like in the contractual, I simply just relocate. But what I'm thinking about is like more like a charter authorized course. But I agree with you. Like I think I can. I think I have some public data on the school bus services. One thing like my agenda is to like roughly calculate what will be the monetary cost.
When you think about the teacher labor market, are you thinking about teachers sorting across all the districts in North Carolina?
No, so in my admission sample, I only include one school district. But if you look at the switching rate across districts among teachers, that is very low, about only like 2% to 3% of teachers switch. So that's why I concentrate just the one school district.
So does the charter school sort of expand the aggregate share of the whole public school, like relative to private school? So do teachers move from private schools to charter schools and students also? What about like your went to the private schools?
That's very possible, but unfortunately, I don't have the data on the private school sector, so I can't really think about like risk switching from the private sector to the public school, public sector. But I do find like in the reduced form analysis, the existing school respond by hiring more teachers, but those new teachers tend to have lower teaching experience, so they tend to be teachers who just new to the market, which is also the reason I bring down this average teacher experience or value adding. Yes.
I wonder if you can try to validate the model with the replication of the motivating evidence in the models, and if charter schools are allowed to accept donations from versus the traditional school.
So first the question, yes, like in the model fit, I do check this pattern, but like in my reduced form, I include schools from all the 3 community zones, but in my counterfactual, it's just a 1 school district, so you can't just really like match the quantity change, but quality, like in terms of the sign, I do find like consistent sign with the reduced form evidence. And second, you're asking like whether charter school can receive donation from the that part I need to check. Yeah.
Try to highlight the importance of the joint sorting model. Do you ever wish to in single sorting model they can also rationalize your pattern? Yes,
so that's why when I do the counterfactual, I simulate the case when I just shutting down the sorting of one side. Or like you're asking other.
No, yeah, in this way, you are doing that. You estimate a joint sorting model and then shut down one side and see that it has not very good fit, but it is not but I suggest a different way. You just try to estimate a single sorting model and see that it is a different story. You just in that way, you're just trying to quantify the importance of teacher preferences. Is not what you wanted to, suggest.
I see. Yeah, that's a good one. I will think about that. I think we can talk about.
Let's welcome the second speaker, Michael from University of Edinburgh.
So hello everyone. Thanks so much for inviting me. I'm Marco from the University of Edinburgh. This is joint work with Dieter Brewerman. Title is Constrained School Choice and the Demand for Effective Schools. This is my job market paper. So first, let me tell you a little bit about the general issue. In general, choosing a school is quite an important decision that parents make regarding their children's human capital. And in particular, an increasing number of school districts are having these centralized markets that allow for some degree of choice. So basically now parents, instead of going to the local neighborhood school, can submit this rank order list, and there is a matching algorithm that assigns the kids somewhere. Now, we know that depending on the properties of the mechanism, the observed application list may or may not represent parental most preferred schools, let's say. When you have Boston mechanism, it really matters what you put first. So there are some kind of strategies. Also, it's quite popular to use the deferred acceptance that in theory is a strategy proof, but most places impose length constraints. Like let's say you can only apply to 10 schools out of 400, let's say, and that might create incentives to misreport your preferences, right? So, but importantly, understanding parental preferences is critical when you start thinking about policy reforms that aim to enhance choice, let's say. So let's think about a market where, let's say, seats are allocated through a one-shot exam and parents can have a length constraint. And let's say you want to move the market to a market of pure choice. Imagine like lotteries and unconstrained choice. That would incentivize that parents should submit their preferences. The effects of such policy would depend on whether parents value effectiveness in short and long run outcomes, or they just care about prestige. Let's say, if they just care about peer quality, this might not create the type of competition that you may want the system to create. Okay? So this is what we're going to do in this paper. We're going to study secondary school admissions in Barbados. So there are these rank order lists. These are the applications parents submit. There is a length constraint, so they can only list a limited number of schools. The priority index this is the way schools rank students. There is just one-shot exam, that's it. So this is serial dictatorship, okay? The questions we're going to address are, first of all, does the length constraint affect rank order list and assignments? We're going to have a policy change that further tighten the length constraint, and we're going to try to address this question. And second, now that we know what happened with the application list, how this constraint affect the application list, we're going to study whether parents value school effectiveness in test scores and wages after controlling for peer quality, but taking into account that perhaps the rank order list do not represent the most preferred schools for parents. Okay? So just to give some intuition as to what I'm going after, let's consider a job market candidate applying for academic jobs, let's say this year, and suppose there is a constraint that the applicant can apply to at most 3 academic jobs, right? So let's assume that universities A, B, and C, or whatever name you think are the most selective and also the highest quality. The question is, would the applicant include these schools in her application list, right? If they only tell you you can only apply to 3 universities, well, perhaps you might skip the ones that you think are impossible, right? So now imagine that we observe data on applications and conclude that applicants do not value quality, right? because it could be the case that they have already skipped all the high-quality universities by skipping the impossible. So is this informative for a market where applicant is free to choose? Maybe yes, maybe not. It depends on what you believe the rank order list is representing, right? So just to give you a preview of my results. So first of all, we're going to have a policy change in Barbados that tighten the length constraint. So there is a binding length constraint in application length, and they're going to further tighten this length constraint. What we're going to show empirically is that parents react by skipping the impossible. Let's say there is a huge drop in the share of parents that list the most selective schools in the market. But second, this might be payoff irrelevant to the extent that, we're also going to see what happened with equilibrium assignments, and we don't see much changes in equilibrium assignments, and we call this payoff irrelevant, like as in the literature, in the sense that they stop applying to schools that they didn't have a chance to begin with. So that's why it's payoff irrelevant, right? And second, we're going to study this question about preferences for effectiveness and peer quality. We're going to do two approaches, right? The first one is quite common in this particular literature that tries to evaluate whether parents value school effectiveness or not. It's just they assume truth telling. They say parents rank their most preferred list, and then we use those application lists to evaluate the weights they put in different attributes. So if we do that with our data, even though we know that they have done skipped impossible, we get similar results as in the literature, that parents do not value effectiveness once you control for peer quality. However, if we use a different approach that takes into account this skipping the impossible truncation, basically we try to get at the preferences without using the information in the application list, following the methods of FAC and Artemov, we're going to find that parents actually value effectiveness quite a lot, even after you control for peer quality. So preferences, they do care about effectiveness, but perhaps in rank order list, that doesn't seem to be the case because they have already done skipped impossible, right? So now let me take you to Barbados and tell you a bit about this market. As I said before, at the end of primary schools, parents submit rank order lists for secondary school admissions. Students take a one-shot standardized admission exam, and that's it. That's the only priority. The algorithm is pretty straightforward. It's a student dictatorship, so you just order the applicants by admission exam score and assign them sequentially. That's it. So this market has a gender quota, so it's half the seats are reserved for boys, half the seats reserved for girls, but this doesn't change much, okay? Now about the policy change, before 1996, parents could list up to 15 schools in the rank order list, but after 1996, they could only list 9 schools. So there was a constraint. I'm going to show the constraint was binding, and then they further tightened the constraint, okay? There were some other policy changes. For example, the schools ranked 3rd to 9 were restricted to those within geographical areas. But we're going to try to, with the outcomes that we measured, we're going to try to isolate the length constraint from these other potential changes in the policy, right? So to tell you about the data, we have data on applications. So basically, we have all applicants to secondary schools between 1987 to 2011. This is roughly more than 20 application cohorts. There are 4,000 applicants per year. This is a very small island. So there are only 4,000 applicants per year, 120 primary schools and 22 secondary schools, okay? We observe application list, the one-shot exam score, the school assignment, and the admission cutoffs of all the schools in every year, okay? So about the outcomes, we're gonna measure this exam called the CSEC, which is an end of secondary exam that determines if a student qualifies for tertiary education or not. So this is a high-stake exam. This is gonna be our short-term outcome. And to measure long-term outcomes, we're gonna match all the application cohorts with a household survey of living conditions. So this is a 2% survey of the population. And in this survey, we have information on wages when the former applicants are between 25 to 40 years old. So we have adult wages, right? So let me show you the policy change and what I mean by a binding constraint, right? So this is from 1987 to 1995. More than 50% list 15 schools, which is the maximum number allowed, right? And then it switches to 9, and then there is again this bunching at the top, right? So the policy change for the constraint application leads to 9, and the constraint is binding before and after the policy change. This is the market we're studying, right? So let's see what happened with the applications. So yes. Yes. Yes, so this could be because these other changes that they implemented at the same time, like not only the length constraint, but they split the island into 3 geographic zones, and some choices have to be from within zone. So if it was just the length constraint, yes, that's true. But as there were other changes, perhaps that's what ameliorates this bunching. So let me show you what happened, with the first and second choices. So these are Harrison College and Queens College are the most popular first and second choices. Let's see what happened, right? These are the share of applicants to this, share of applicants to Harrison College as the first choice, share of applicants to Queens College as the second choice. These are the most selective schools in the island, right? So these are the most demanded, the most selective, and now the proportion of parents listing them as first and second choices decreases by quite a lot. So I'm showing you the, non-parametric beans estimates, but you can put like an RD type of specification or a, trend break, extraction break specification, and you're going to find that it's roughly 35 percentage points decrease, right? So it's quite a big decrease. Now let's see. So that's if you put it first or second, right? Now let's see what happens if you apply to these schools at all, like whether perhaps you stop applying completely, like you skip the impossible, let's say. So in panel A, what we have is, again, this big discontinuity in, the share of parents that apply to these schools anywhere in the rank order list. So yeah, that's 30 percentage points, but perhaps, there might be some other things going on in the market why this trend might be decreasing. So what we're gonna do is that we're gonna see what happened with the top scorers and what happened with the, let's say, not so high scorers. So this discontinuity does not happen for the top scorers, which is reasonable because the top scorers actually still have access to these schools. But we're gonna use this difference between top scorers and no top scorers to do some diff in diff specification. And, this would be our most conservative estimate, and it still is 20 percentage point decrease, okay? So about the composition of students at different schools, what I said before, there is this gender quota, so there are not gonna be gender differences in the assignments, So everything I showed you before is about applications. Now let's look at equilibrium assignments. So what can change is, the test scores or the skills of students allocated to different schools, or the socioeconomic of kids allocated to different schools. We're going to show that, we're going to divide, the schools into these big 4 schools that are historically the most prestigious and selective schools in the market, and we're going to see if there is a change in the composition, at the policy time, and we find that there's no major change, right? Either in the admission exam score of the admitted students or in the socioeconomic index that we create from the census. So, and that's what we mean by skip the impossible, right? So the applications change, but the equilibrium assignments do not seem to change. And the reason why this is happening in this market is that, this is basically telling you how many, there are 120 primary schools, but there are 10 schools that are, let's say, primary schools where choice is not centralized and it's just by residential areas. And the students from these 10 schools take half the seats at the most selective schools in the market every year, before and after the policy. So in that sense, it's payoff irrelevant, right? So if you didn't go to one of these schools in primary, your probability of being allocated to one of these super selective schools is pretty low, let's say. And parents know that, right? So now, after I show you that, rank order list change with the policy, we're going to try to study, parental preferences, or what do parents value when they make their choices. And perhaps, the application rankings are not that informative in that sense. So let's define, the utility. It's just a standard framework. You have that school characteristics and unobserved school attribute and distance. Okay, we can complicate this as much as we want. Let's keep it simple for now. So this delta J is going to measure average states for school J. Xj is a vector of school characteristics. In particular, we're going to add as these school characteristics school effectiveness on test scores and wages and peer quality, the way we're going to estimate it. I'll show you how we estimate that later. And we're going to calculate distance from each student to each school. Okay? Yes? So the way it works is that the parents submit the applications in January. At the end of January, the exam is by the end of April. So they have expectations, which would be a concern about the stability of the market if the mistakes were payoff relevant, right? But we're going to try to argue that most of the mistakes are payoff irrelevant, and that's our argument why we can use the stability of the market to estimate preferences as an alternative. Yes?
So the X's are exogenous fixed, or are you going to allow them to be, for example, peer quality to be an endogenous outcome of the model?
For now, they are fixed exogenous, they are estimates. So we're going to construct these measures. Yeah.
But in a counterfactual environment, they remain the same. So the applications changed probably, well.
Yeah, so if we were to do a counterfactual, we would need to take into account that these are equilibrium objects, right? Mm-hmm. And yeah, we would need to take into account this peer effects literature on. But at the moment, we're just showing how much weights they put. Okay?
Is there any incentive effects for choosing ranking very selective schools at the top and second choice? Instead, in the sense that if I feel in HKU as my first choice, then I will really be paying hard in doing this exam prep, which will happen 3 months later.
So regarding the first and second choice, is not the Boston mechanism where the first choice really matters. It's serial dictatorship, like deferred acceptance. But yeah, I mean, kids prepare for the exam. Let's just say that. And yeah, I don't know. I'm not sure I understand your concern.
Yeah, so before the policy, you said that after a policy, people basically don't feel in their impossible schools. But before that, they feel in their impossible schools, and that particular application behaviors can incentivize the learnings there before the exam, because the exam score is realized later than the ROL period.
Mm-hmm.
So is there any evidence on this?
So I don't have whether there is a endogenous response. I can see, if the application scores have changed, but I don't have a study effort before and after the policy as to see whether the new system induced people to study more or less, let's say. I don't have that information. So about how are we going to estimate the preferences? Well, first, we're going to just follow the literature, and we're going to use observed application list and assume truth-telling. Okay, that's the most straightforward one. That's the one that a lot of papers do that study this type of questions. Okay, and the second one, we're going to use this. This is just, you match the probability of observing a given ranking. Second one, we're going to follow a literature that uses stability of the market, which means the stability just means that you get assigned to your favorite school that is feasible, right? So there is a feasibility. So there are going to be heterogeneous choice sets determined by feasibility, right? And that's why, there's another way to recover the preferences without using data on the rank order list that you might think maybe they already skipped impossible, right? Just to give some intuition, let me just give you an example. So let's think of a market with 5 schools where parents can rank at most 3, okay? Assume schools A and B are the most selective and effective. So these are the preferences, right? And this is what I mean, between the black and the blue letters. This is what I mean by the truncation, right? In theory, whenever there are list length constraints, it's not that parents flip the order of things. They still submit applications in the order of preferences, but there is just a truncation, right? But the truncation, I mean the skipped impossible. So let's say you observe the rank order list, C, D, E, that's the truncated preferences, and the match is C. So what truth telling would do here when you observe CDE, truth telling its most standard application, it would say like you prefer C than D, E, A, B, D than E, A, B, and E than A, B, right? That's what it would say from the ranking. And the issue here is that if A, B were infeasible, then this might, and A, B were infeasible, and these are the most effective schools, this might bias your estimates of how much parents care about effectiveness, right? Whereas the stability assumption, what it's going to do is just going to say like, okay, A and B were not feasible to begin with, you ended up allocated at C, so all I can infer is that C is preferred than DE. And that's what we're going to do, right? So we're going to use both approaches to recover the distribution of preferences and show what we get, right? So let me show you the, yes. So yes, at the moment, I don't have like, there is uncertainty. I would need to add an expectation, right? About to the extent that, yeah. So in principle, if there is truth telling, you don't care about your test score, right? Now, whenever there is stability, yes, there are like an extension of the transitive axiom of TEPS approach, which basically, if you have a function that maps, what you observe into the test score, you can take repeated draws and then still estimate things by stability. I'm not doing that right now because I don't have other skill measures. I'm just assuming that the ex post feasible set is what it is. But yeah, so I would need to think about how to add to the stability approach with the information that I have, the fact that the test scores are not observed at the time of publications. Yes.
Secondary school application.
Yes.
Do you have data on primary school as well?
So all I know is the primary school where each student attended. I don't have like their grades in primary school or anything. I could try to get the data, so maybe. Yes, so there are some papers that study this as a dynamic thing. I don't have the data to do the full dynamics, but I'm just focusing on the secondary applications at the moment. Okay. So yeah, so let me show you the estimates. These are the delta J, the average taste. And as you may have guessed from before, under the truth telling, they are not so high. These are the red ones are the truth telling estimates, right? The schools are ordered in order of selectivity. The higher number means most selective, which might be confusing, but the higher number means most selective, right? So if you do truth telling, there is no high average taste for selective schools, whereas under stability, the highest average taste are for the most selective schools, right? That's basically what we get here. Now, the other things I've been talking about, effectiveness and peer quality, we're gonna try to estimate these objects, right? So let's define potential outcomes, and let's have, alpha J is our measure of effectiveness, and then we define peer quality following this notation, right? Basically, the average outcome of students at all schools is the average student ability, and then the expectation of that for those allocated to a given school, that's what we call peer quality, okay? Now, so basically we need to estimate this alpha, J, and beta, so we're gonna do it in different ways, right? The first one, the most straightforward, value added, right? Let's say under selection on observables, we do a value added specification, we get alpha J's and problem solve. But then we're gonna do more than this, right? But let's begin with the simple. So this is what we'll find regarding effectiveness, right? So on the left side, you have test scores. On the right side, you have monthly wages. So if you just think of outcome averages, you overestimate effectiveness, but still, the most effective schools, the most selective schools are the most effective. Remember that the indexes are, index 22 would be the most selective, right? So yeah, there is this pattern that also happens in other markets. The most selective schools are the most effective. And as I said before, we're going to do some robustness regarding these alpha J's estimates, right? The first robustness we're going to do, because we have a choice model, we can incorporate a control function. So we allow for selection on observables using the choice probabilities from the choice model and an exclusion restriction. So that's one robustness. And it's not going to change much. Second thing we're going to do is that this is a serial dictatorship, right? So there are a lot of admission cutoffs and there are a lot of discontinuities. Thank you. So we're going to exploit the admission discontinuities generated by the serial dictatorship to assess bias in our value-added estimates. We're going to find that they seem to be fine on average, right? And lastly, as I showed you before, we have more precision in the test score estimates than in the wage estimates because the wage estimates come from a survey. So we're going to use multivariate empirical base so we can do shrinkage, right? So we combine estimates on both outcomes and then we shrink them, right? Now, this is what I was telling you about, now that we have the delta J's estimated on the two approaches, we have alpha J's and we have peer quality estimates. We're going to compare, the composition as to what do parents care about, right? So if we assume truth telling in the first column, it seems that this is what the literature tends to get, right? That once you control for peer quality, parents do not value effectiveness anymore in test scores. Whereas if you assume stability, they seem to care about both peer quality and effectiveness. We are going to do this, also allowing things to change by year. So in the second set of results, we basically have more observations, and then we're going to do the same for monthly wages. But for both outcomes, the pattern is the same. So if you assume truth telling, parents do not value effectiveness after controlling for peer quality, whereas under stability, parents value both effectiveness and peer quality, okay? So to conclude, schools matter for short and long-term outcomes, right? So now, whenever there is a constraint in the length of rank order list, parents trade off effectiveness for admission probabilities. So they trade off selectivity, in principle, but selectivity is highly correlated with effectiveness, right? So basically, they take into account these admission probabilities and they do this skip the impossible, which means they stop applying to these highly effective schools. Now, in this context, rank order lists may show a lack of preferences for school effectiveness on test scores and wages, even though in the distribution of preferences that is observed, parents do value this attribute a lot, right? And in fact, the more they value, the more selective they become, and the more the truth-telling estimate is going to be biased, right? So this result, in some centralized markets, effective choice sets are narrowly constrained in practice, right? Especially when you have one-shot exams and serial dictatorship, In this market, in particular, parents seem to recognize these limits. So they seem to know some schools are just completely out of reach, right? I'm not going to make it there, and I know that. So in these particular markets, or at least in this market where I observe that they do value school effectiveness, it's not that they need more information on, value added or effectiveness, as, they have done some experiments and they tend to find that it doesn't change rank order list that much, and even less, it changes application, it changes equilibrium assignments. So in some markets, they don't need more information. What they need is just more choice, right? Thank you.
What are the stated motivation for choosing
So the government, when they choose to shorten the list, the motivation was that they wanted kids to go to schools that were closer to home. They thought they were going too far away, right? So the presumption was that by shortening the list length, they were going to go closer to home. Now, I can see that in the data, and that's not what happens, right? It's not that I can see the distance to the assigned school and see that that hasn't changed that much after the policy implementation. Yeah, but that was the motivation. Yes. Yes. Sorry?
This limit on the number of applications applies to public schools only, right?
Yeah, this is public school choice. Yes. It's minimal. So this is basically 97% are public schools. It's a very small island, let's say. There are very few private schools. Yeah, so ciao. Yes. Yes. Yes, so that for me would be the next step. Like it's like if I have the ex-ante admission probabilities and I can actually estimate the full optimal portfolio with some kind of ex-ante admission probabilities, my hope is that I would get the same as when doing the stability approach, because I believe perhaps that's not so wrong. But I'm working on that at the moment. Thank you.
Thank you.
So hello everyone, my name is Guillem from Toulouse School of Economics, and today I will talk about how student financial aid can affect enrollment, effort, and graduation in higher education. And this is an ongoing project with Juan also today at the conference. So governments have used multiple funding instruments to attract students into higher education, and in terms of loans, scholarships, that can be means or merit-based or a combination of the two. And also in recent years, there has been brought into the public debate the fact of completely financing tuition, so free college, in particular in countries in which student debt has been a big burden. So for instance, the last Biden administration had a project of making community college for free in the US. And there has been some attempts in recent years in Latin America, such as Colombia or Chile, for which I will be focusing on today. So advocates of free college usually argue in terms for equity reasons, so to enhance equality of opportunity, but it also has some efficiency reasons. So students are credit constraints, removing the tuition will facilitate their access into higher education. But on the other hand, it can also affect incentives to exert effort in higher education. It can lead students to over-consume higher education, and even it can affect incentives to sort efficiently across institutions and majors. Finally, such policies can also have regressive concerns as students from more high socioeconomic background are more likely to be enrolled into higher education, so that in practice we will be subsidizing students that would have to go into higher education anyway. So the details of any education policy will inevitably have impact on the pool of students that we will attract into higher education. So the goal of this project is basically how we can target this financial debt. We will try to answer this question in two steps. First, we will use quasi-experimental evidence about free tuition policy in Chile, which made tuition free for the lowest half of the income distribution. And we will analyze its effect using difference in difference approach. What we find is that for eligible students, enrollment increased by 5 percentage points in 2016 and up to 15 percentage points in 2017. And this is driven by the low ability students. And the specifics of the policy will allow us to identify effects of the reform on inframarginal students, those that would have enrolled anyway. And there we find that dropout decreases by 2 percentage points, and it improves on-time graduation. So then we will try to switch and investigate with the model. So it's free college lowers entry barriers and alleviates financial stress, so students may perform better on the free tuition, but on the other hand, it can attract students into higher education that might overconsume and exert and have high effort costs. So we will build a structural model of enrollment and credit completion in which effort will be endogenous and unobserved. And this will allow us to separate marginal from inframarginal students so that we can recover the full distribution of treatment effects of the policy. And the model will identify the marginal cost of effort so that we can predict what would happen in counterfactual funding schemes. So let me tell you a little bit about our contribution. So very briefly, there's a large literature that determines the impact of financial aid on enrollment, and they find that students are quite sensitive to aid, so effects are quite strong for even moderate amounts of financial aid, but results on educational outcomes are a bit more mixed and with less evidence. So here we will evaluate the impact of a large-scale free college policy in the context, and as I will explain to you later, where financial aid is already quite well developed. And secondly, we will contribute to dynamic models of educational policies that focus on effort and precisely on effort. So the first round of literature looks at effort and academic outcomes, such as effort and subjective beliefs in the case of Tim Carney, or affirmative action policies. And here we will focus on financial aid, and we will endogenize the effort of the students that will be unobserved, and we will recover through observed measures of outcomes. So let me tell you a little bit about the context. So we are focusing on Chile, in which the higher education is quite well developed. In particular, it has experienced a large expansion in the last 30 to 40 years. And students access higher education after taking the national exam. So it works as a deferred acceptance algorithm. So as in the case of Marco, it's limited to 10 listings. And tuition is among the highest in OECD countries. And tuition is around half of the median annual wage. But, as I was saying, funding options are already quite well developed. So there are subsidized loans that only depend on your score in the national exam, and scholarships that require some higher score, are limited to the lowest 8 income deciles, and has a performance requirement that you should pass 70% of the yearly credits to maintain. And it covers on average around 80% of the tuition. So just that you see graphically what is happening with the pre-college policy. You have family income decile in the x-axis and the national exam score on the y-axis. So you see that to access the loan, you only need a score, and scholarship is also conditional on income. With the free college policy, this remains the same, but you have a new set of students that were on average lower ability that now has free college. Those that have a loan also experience a subsequent subsidy from the government, and those that were already eligible for scholarship have an extra 20% of tuition available, which is not negligible. You can think about $1,000, and the performance requirements are removed. So yes.
EY is the lowest income of highest income.
Sorry?
EY is the lowest income of highest income.
This is the lowest income.
So for highest income, you have to provide a loan.
For the first, yes. So loans is irrespective of income. Only depends on your score if it is. So as you see, those that were already, so this is, I split the panel between so those that are between decile 6 and 10 on the top panel, and between 1 and 5 in the lowest panel. They were already eligible for a lot of student aid. So those are loans and scholarship. Only a small amount of students had no public aid, maybe because they were in some colleges were not eligible to the policy. Those are private or with low accreditation. And starting in 2016, free college replaces most of the existing ed. So the story is mainly about the substitution of funding. The high ability get this extra 20% of funding and with no performance requirement. The mid ability now can fit from loan to free college, and those that had no public ed, that were the lowest ability, will now have access to free programs. So we will first look at the effect of the policy, but let me talk to you about the data. We were using Chilean administrative records, so we have the universe of students that took the test with the demographic scores and characteristics, and we have the yearly credits that they register and complete, and we complement this data with survey data to look at labor market expected wage. So the results of the quasi-experimental evidence. So we use a two-way fixed effect regression where eligibility is given by belonging to the lowest 5 income deciles, and X is a vector of covariates including gender, model education, and a measure of ability. So what we see is that starting in 2016, enrollment for the eligible students increased by 5 percentage points, and a bit more than 10 percentage points starting in 2017. And if we decompose these effects by the 3 groups of students by ability I was showing before, the lowest ability students seem to be driving a bit more these results. So the largest effect on enrollment was driven by this lowest ability. So if we want to look at educational outcomes, it's a bit more tricky because we have this competition effect. Maybe the pool of students for which we are looking at now are not the same as those that we had before. So we will use the fact that the policy started in 2016, but those that were already enrolled also benefited from the policy. So if you enrolled in 2015, you could potentially benefit for the 4, so the green has 5 years in Chile. So if you registered 1 year before the policy, you had 4 years available of pre-college. If you enrolled in 2013, you had 3 years available, etc. So these are students that benefit from the policy, but that could not change their enrollment decision. So these are by construction inframarginals. And we use the same sort of regression to fixed effects. And what we find is if we look at dropout, cohorts prior from 2012, they were not eligible. From 2012 to 2015, are students that could not change their enrollment decision, so strictly inframarginal. And from 2016, it's potentially a combination of the fact that there's a new pool of students that enters into higher education. So for inframarginal, dropout decreases up to 2 percentage points, and graduation in the same at the initial major increases by 4 percentage points. And we will see that the effects actually are even reversed when we look at cohorts starting in 2016. So basically no effect on graduation. They graduate at the same rate as prior to the policy. And for dropout, we see even a small 2% points increase. So to disentangle this effect, whether the policy has positive effect on educational outcomes, and it's just that students that are brought into the policy have some higher marginal cost of effort, we need a model to try to disentangle the two. So this is just the recap of the results. So just to look at the model, so the state variables will be the year in which students are enrolled, out-of-pocket fees, the program in which they are enrolled, and then G and capital G are the last periods credits completed, and we keep track of them into the cumulative credit completed. And Z will be just the vector individual characteristics, such as ability, female, and socioeconomic background. The choices of the student will just be field, institution, combination J, and at each period they will choose an amount of continuous effort level from 0 to infinity. Regarding the timing, at the entry, they will observe the available funding instruments and choose a program field combination J and an amount of effort. And then from periods 2 to 7, we allow up to 7 periods per student. They observe the previous outcome, how many credits they completed in the previous year. This will determine the funding if they are eligible for scholarship, and they will decide whether to continue or drop out and choose again an effort level D. Yes? There's an alternate option. So if they don't, they will choose J equals 0, which and they will directly earn a wage. Yes.
It will become more harder than the selection fee.
So this is the rule, yes. Yes. And at the terminal period at equals 7, those that are not yet graduated are assumed to have also a dropout. We will specify the flow utility as a negative cost of attending higher education, composed of a fixed cost that will be preferences for programs, and a variable cost composed of a marginal cost C that we will identify from the model, and effective effort. Why do we call effective effort? Because it's recovered to observed outcome. So a student that passes a lot of credits will be given assigned the fact that he exerts a lot of effective effort, but this might just be that he had a lower marginal cost of effort, so he can exert a lot of them. And out-of-pocket fees are given by the fact that so the price of the major and a proportion lambda that is fixed by the government, and that depends on the student characteristic set and potentially the past performance if they were eligible to the scholarship. The utility shock is assumed extreme value type 1, and starting in 2016, the policy made the out-of-pocket fees irrelevant of either the price or the past performance. So how do we model this performance and effort? So effort would have an impact on performance, and by exerting more effort, the student will increase the probability of passing a certain number of credits G. So effectively, by choosing effort, the student is choosing the distribution of performance. So outcome, the outcome depends in a concrete fashion on effort. By exerting more effort, he increases the chances of, so in practice, we discretize the completed number of credits from 0 to 4, and by exerting more effort, he will increase his chances to have a higher number of credits. So if we use, so we assume the shock eta to be logistic, so we can retransform the above equation, and we can interpret effort as the probability to avoid the lowest outcome. And graduation will simply occur as when the number of credits equals the ones required by the program. Yes.
Sorry if I missed, but how students are different in terms of the profitability of the effort? Are they different?
Yes, so they are different, but for now only on observed characteristics. So every student will have a different marginal cost of effort depending on probability, income, and also it will depend on out-of-pocket fees. So then we can build the conditional value function. So the flow utility, and then we integrate over the possible 5 credit states in future periods. And this is, so 5 will be the probability to obtain a certain number of credit states. So we will integrate over the 5 possible credit states in the next period. If students are maximizing this conditional value of a function with respect to effort, and we take the first order condition, the flow utility derivative with respect to effort gives us directly the minus marginal cost plus a term that if we equate to 0 from the first order condition, we get that marginal cost of effort will include the marginal benefit. So this will just be the derivative of logit probabilities, and the ex-ante value function that I will explain now in estimation, we can directly retrieve from the data. And the student will end up choosing the program with the highest utility after solving for effort in each of the available programs. So how are we going to estimate this? Given the type 1 extreme value assumption, the CCPs will be of logit type, and following Hodge-Miller, we will use the dropout as a terminal action such that we can have replaced the ex-ante value function by the dropout weight minus a log correction term that will depend on the probability of doing dropout, conditional on the state variables. So in the first stage, we will try to recover the dropout probability and the effort from the data. So we will model dropout as a logit model, and we can see that from the state variables, it is quite predictive. So as the out-of-pocket fees are higher, they increase the likelihood of dropping out. The same is true for the distance, and cost performance in terms of cumulative credits, or even delay seem to matter a lot for student dropout. And regarding the effort variable, as I said, we discretized the amount of credits into 5 categories, and we run another logit model, and both socioeconomic status, ability, and cost performance in terms of cumulative credits or credit completed seem to predict a lot the amount of credits that students will be completing. So we first recover these 2 objects from the data, and then from the first order condition, we can equate marginal cost to marginal benefit, and we can replace this expression on to the conditional value function. So we have an expression for marginal cost. We replace this in the flow utility, and we can estimate the whole expression to retrieve fixed cost using maximum likelihood. So in practice, using a conditional logit model. And finally, using the estimates of the fog, we can retrieve the distribution of marginal costs. So just to look at the results, we first estimated the fixed cost of students for programs. So as out-of-pocket fees rise, students have higher marginal cost. Distance also impacts the fixed cost of students for attending a particular program. And interestingly, it's even higher for students with high ability, so in terms of PSU and GPAs. Expected grades of the program also seems to matter a lot when students are in the major institution choice decision. And here we make it granular, so we include field and institution its effects. Then we can retrieve the distribution of marginal cost. So this is a plot in which we have income decile and PSU, so ability in the y-axis, and we see a clear gradient of marginal cost. So as students get or more or smarter or of a higher socioeconomic background, they seem to have it's easier for them in terms to produce effort in higher education. So where do we want to go with that? So first of all, we want the model to recover the full distribution of treatment effects. So we have a measure of fixed cost and marginal cost for all the possible counterfactual choices of the student. So we can compute treatment effects even at the individual level. What would have happened to that student if he would have enrolled to a program instead of the dropout option, or by switching programs? And then ideally validate the reduced form results, the definitive results using the model. And finally, we would also like to look at optimal policy. So this was a very expensive policy in Chile. So both of the proposed options are budget reducing. So either reintroduce the merit and performance requirement, as it was in the case with the scholarships, or vary the subsidy amount, in which we see that students that have a low, not so high marginal cost, those that have a very marginal cost are deterred from entering higher education. So I think we also thought about looking at the major choice, but I think I'm running out of time. So we saw that the free college lowered barrier entries and increased enrollment into higher education. This was driven by low ability students, which induced a composition effect. And the policy had the educational outcomes for inframarginal students seem to have decreased dropout and increased graduation rate. And the model we built of enrollment and credit completion will potentially allow us to distinguish exactly between the marginal and inframarginal to recover this full distribution of treatment effects. So this is all. I think I'm out of time. If there's any question. Yes.
I wonder if the empirical evidence, more direct evidence to show a decline in effort. For example, there's sports.
Yes.
Don't need to take tax for scholarship.
Right. So the data I have is only about credits, and it starts after the policy. So what I have is the percentage of completion during their enrollment. So they complete their credits in the first year and they find it easier later. And I can do comparisons for students that are not eligible, but I don't have a clear variation of the policy pre-post for the credit completion.
Very possible manipulation of the and their possible manipulation of how many
So it's self-reported and then checked by the administration. So at the margin, it would be possible. So I have talked to the administration about that. They say they have no evidence of this happening, but at the margin it could happen. Sorry? No, because since I only have the income decided, a more granular measure of income would allow me to see that. But at the income, at the design level, I don't remember, but maybe it's not granular enough.
Okay, right. Thank you.
Thank you.
We'll have a